Greetings everyone, welcome to AK Online Academy. Alright, in today's session we will be concluding the topic we've been looking at, which is quadratic function graphs. So there are scenarios when the examiner will give you a question. We are used to having the graph already drawn for us, but in this case they will ask you to draw the graph. So they'll give you the function for the graph and then they will ask you to draw the graph. Okay, and also there are other cases where they will draw the graph for you quite alright, but they will require of you to find the equation for the said graph. So this information up here is going to be helpful when it comes to these types of questions. So what we have up here, it says when a is less than 0, then the graph is going to be a frown. So this information up here helps you determine whether the graph is going to be a hyperbola or a parabola, whether it's going to be a frown or a smile. So now, what is this a we're talking about? Remember when we introduced this topic, we had this formula. Okay, this is a general formula for a quadratic function graph. Okay, so the a being referred to is simply the value here. Okay, so we said a, b, and c represent numbers. I'm sure you remember that. Okay, so if according to the function of the graph, if the value of a is greater than 0, then it's going to be a smile. If the value of a is less than 0, then it's going to be a what? A frown. Okay, now what are examples of numbers that are less than 0? All negative numbers are less than 0. So if the coefficient of x squared is a negative number, meaning you know to say your graph is going to be a frown. For example, this one right here, you can see it is a frown, right? So meaning the equation you should find here, the coefficient of x squared should be a negative number. Because according to this, when a is less than 0, when a is a negative, that's when you have a frown. But when a is a positive, that's when you're going to have a what? A smile. So that is that. Let us now look at these questions with that in mind. So question 1 says, a function y is equal to open bracket 1 plus x close bracket open bracket x minus 2 close bracket. This is the function for the graph. And now they are saying sketch the graph of the function in the answer space below. So in the exam paper, there's going to be something like this provided for you, where you're supposed to draw the graph. Okay, this is what they're referring to by saying in the answer space below. So you have something like this and you'll be required to draw the graph from here. Okay, so now before you draw the graph, you need to determine a few things, because as you can see, there's this graph here which is just on the left side of the x-axis in the negative region. Okay, so you need to know, is my graph going to be in the negative region? Is it going to be in the positive region? Is it going to be is it going to cut through the positive and the negative region? Is it going to be a smile? Is it going to be a frown? Okay, all those things you need to be able to figure them out. So in order for us to determine where the graph is going to cut, whether it's going to be in the negative region only, or it will cut both the negative and the positive, or it will be just in the positive region, we need to solve this quadratic equation. Okay, we find the x coordinates, because the x coordinates are going to tell us where the graph is going to cut through the x-axis. So that is what we're going to do right now. So we are going to say question 1, Roman numeral 1. So we're going to say 1 plus x, the x minus 2 close bracket is equal to 0. You remember this information from the previous session. Okay, and then here we simply equate each bracket to 0. So we're going to say 1 plus x is equal to 0, or x minus 2 is equal to 0. So meaning x here is going to be 0 minus 1. When this one crosses, it becomes negative. So x there is going to be negative 1. Or x is equal to 0 plus 2, or x is equal to positive 2. So we have determined where the graph is going to cut through the x-axis. On one point it will cut on a negative 1, on the other point it will cut at positive 2. Okay, now that we have determined this, let us now determine whether it's going to be a frown or a smile. So in order for us to determine that, we need to come up with the original equation for the graph. So we're going to get this same equation, which is 1 plus x, and then we have x minus 2 is equal to 0. Okay, so we now need to expand this equation so that we can now find the original equation for the graph. So we're going to say 1 times x is going to give us x, 1 times negative 2 will give us negative 2, okay, and then x times x will give us x squared, positive times negative, negative, x times 2 is going to give us 2x is equal to 0, and then we can group the like terms. So I'm going to say, let's bring this guy right at the front, x squared, and then let's put these two values together. So this one is a positive, and then this one is a negative, and then the constant, let's take it right at the back, okay, is equal to 0. So this guy has come here, okay, this one has come here, this one has come here, then this one, we have grouped them together since they're like terms, then the constant at the end. And then here we can finish off by saying, there, what are we going to get? We are going to get negative x minus 2 is equal to 0. So that is going to be the final equation, the original equation for the graph. So at this point, we can now determine what is the coefficient of x squared. What is the value of a? So you can see here that the value of a is what? Positive 1, which is greater than 0. So meaning this graph is going to be a what? A smile. So at this point, on the answer space provided, we can do this. Okay, so this is our x-axis and this is our y-axis. The coordinates we have where it is passing are these ones here. Okay, it is cutting through the x-axis at negative 1. So let's say we have negative 1 here, and then here we have positive 2. So if this distance is negative 1, we can say positive 1 here, then we say positive 2 here. So it may not be drawn according to scale, but it has to make sense. Okay, imagine the distance from here to there is the same as the distance from there to there, and you put positive 2. It won't make sense, right? Yeah, so that is that. Let us just try to extend this line a bit, and we can have our graph looking like that. Okay, initially it's supposed to cut through the point we put as positive 2, and then we can also name the graph. We can now say y is equal to, we can either use this one or the one they gave us in the equation, which is that one. You can say 1 plus x, and then x minus 2 as the name of the graph, and you're done. Okay, we now come to the next question, which says find the minimum value of y. So you remember from the previous session, so allow me to keep this information because I'd like to use it when solving the last question. So let me just erase this part down here. So now to find the minimum value of y, we first need to find the x coordinates. So how do you find the x coordinate? We're going to say x is equal to, I gave you two formulas last time. You can use either one of those formulas I gave you from the previous session. Okay, so I'll use this one. What is our b? Our b here is negative 1. This is the original equation to come up with. So our b is negative 1, so then you're going to have negative 1 like that. Since this negative is part of the formula, and this value is coming with its own negative, and then 2, what is the value of a? The value of a is simply the 1 there. So meaning x is going to be equal to negative times negative, positive, 2 times 1, 2. So the x coordinate is basically 1 over 2. Now that we have the x coordinate, we can replace every x in this equation to find the value of y. So we're going to say therefore y is equal to this equation, x squared minus x minus 2 is equal to 0. So y is equal to, so where there is x, we put that one. So we're going to say 1 over 2 squared minus 1 over 2 minus 2. Okay, y is equal to 1 squared is 1, 2 squared is 4, minus 1 over 2 minus 2 over 1 common denominator 4. Okay, 4 divided by 4 is 1. 1 times 1, 1. Bring down that sign. 4 divided by 2 is 2. 2 times 1, 2. Okay, bring down that sign. 4 divided by 1 is 4. 4 times 2, 8. 1 minus 2 gives us negative 1. And then we bring down the negative 8 over the 4 there. There, when you simplify, we're going to get negative 9 over the 4 there. So meaning the minimum value of y is negative 4 over 9, and you're done. Okay, if you want, you can leave it here, or you can convert it to a mixed fraction where you say 9 divided by 4 gives you a negative 2, and then we have negative 2 as a whole number, and then you're going to have that there. So either this or that guy up there as the minimum value of y, and you're done. We now come to the next one. So this is the one where they draw the graph for you, and then usually they will ask you to find the coordinates where the graph is cutting through the y-axis or the x-axis. But in this case, they've given us the coordinates where this graph is cutting through the x-axis, and now they want us to find the equation of the graph. Let's read the question. The diagram shows a sketch of the graph of a curve passing through a negative 5, 0, which is this point here, and b negative 1, 0, which is this point here, negative 1, 0. And now they're saying find the equation of the curve. So for us to find the equation of the curve, we simply need to solve this quadratic equation in reverse. Let us see how interesting that is. So if you remember from the previous session, let's start from here. Okay, here we are finding the coordinates where the graph was cutting through the x-axis, right? So this is what we have here. These are the final coordinates we have, which are the same as what we have there. So let us write them down. So meaning, question 2, Roman numeral 1. If we are solving for this one, we are going to say our final answer will be negative 5 for x is equal to negative 1. If we are solving, if we are trying to come up with these coordinates, the final answer would look like this, right? So now we need to go back in reverse to this point so that we can, this is the same as this one, right? When we expand, that's when we find the original equation. So now from here, let us go back in reverse. So what happened here? This one, if you notice, the one was on the left side of the equal sign. It had to follow the 0, and then after we simplified, this is what we did. So meaning this 5 will have to follow the x so that we can remain with a 0 here. So I'm going to say x is my x plus 5. Since it's negative, when it crosses back, it becomes a positive, and then there we're going to have is equal to 0. This is the same as what we have there, except the x and the 1 have different positions. Okay, even this side, the negative 1 will have to cross and follow the x. So it will be x plus 1 is equal to 0. Okay, at this point, what we have here is what we have there. And then going backward, it simply means these values, we simply need to put them in double brackets, like they are here. Okay, so meaning we're going to say x plus 5, x plus 1 is equal to 0. And now for us to find the original equation, we're going to come to this step. This is what we did to find the original. What did we do? We expanded these brackets. This bracket multiplied with that bracket. Okay, so we're going to say x times x, x times 1, 5 times x, 5 times 1, like that. Okay, so meaning we're going to say x times x gives us x squared. X times 1 gives us x. 5 times x, 5x. Okay, 5 times 1 gives us 5, which is equal to 0. If we simplify further, we're going to have x squared. X plus 5x gives us positive 6x, and then you have the plus 5 is equal to 0. Okay, we are nearly done. We're almost there. So now this is the original equation. But then, remember this information up here. Okay, we're told to say when the value of a is less than 0, then it is a frown. Now look at this one. It is a frown, right? Okay, and what are the examples of values that are less than 0? We said they are all negative, right? So whenever it is a frown, meaning the coefficient of x is a negative. But in our case, the coefficient of x is what? Is a positive. So what are we going to do to convert it to a negative? So what we are going to do is we are going to say, at this point, I can erase this information up here. So if the graph was a smile, we are going to leave it the way it is. But since it's a frown, meaning the value of x needs to be a negative. So what we are going to do is we are going to say y is equal to negative ax squared plus, so in brackets, plus bx plus c. Okay, this is what you do when your graph is a frown, meaning the value of x needs to be a negative. So what this is simply going to do is we're going to multiply all the values inside the bracket with a what? With a negative. So this is being represented by what we have in the bracket. So we're going to say y is equal to negative, and then we plug in this quadratic equation. X squared plus 6x plus, is it 5? Yes, 5. Okay, then we're going to have y is equal to x. Negative times positive there will give us negative x squared. Negative times positive, negative 6x. Negative times positive, negative 5. So now this is the original equation of the graph, and we can actually prove that it's correct. How can we do that? We can try to solve it. So let's try to come up with the factors, right? Okay, what's our sum and what's our product? Our sum is basically that value there. We have done this a lot of times, so I expect you to follow me up to this point. Okay, what's the product? The product is found by multiplying a times c. Our a is negative 1 here times that, giving us positive 5. What are the factors of the product? It's just 1 and 5. And then we said you have to make sure that the biggest number in the bracket should have the same sign as what? As the sum. Okay, so meaning since our sum is negative, this guy has to be a negative also. And when you multiply these numbers, they have to give you the product. Let's try. Okay, 1 times negative 5. What does it give us? It gives us negative 5. But our product is a positive. If you remember the lesson on integers, we said you can only get a positive outcome when you multiply the same signs. Okay, so we're aiming at getting a positive. Okay, meaning we need to multiply two negatives. Since we've already determined that the bigger number here should have the same sign as the sum, so meaning even this smaller number should be a negative, so that when we multiply the two, we get a what? A positive outcome. So meaning this is also supposed to be negative, negative like that. So when we say negative times negative, it gives us a positive. So the numbers we are actually looking for are negative 1, negative 5. These are the factors we're looking for. Okay, and if you check down here, what do we have there? Those are the same numbers we have. So that is that. So meaning the original equation of the graph is this one we have up there, and we have proven that it is correct. Right. So now that we have done that, we can go to the next question. So this here will be our final answer. Let's go to the next question. So the next question says, find the coordinates of the turning point. The solution is the same as when you're finding the minimum value of y. So we're first going to find the x coordinate. How to find the x coordinate? We're going to say x is equal to negative b over 2a. Okay. What is our b? Our b is negative 6. So we're going to say negative 6 over this value of b is coming with its own sign. This negative is for the formula. And then we're going to have 2 in brackets. What is the value of a? The value of a there is negative 1. Okay? Which gives us negative times negative, positive. 2 times positive times negative, negative. 2 times 1, 2. Okay? Positive divided by negative is negative. 6 divided by 2, 3. So the value of x is equal to negative 3. Now we need to find the value of y in order for us to find the coordinates of the turning point. We have found the x coordinate, we now need to find the y coordinate. So how do we find the y coordinate? We use the same equation of the graph. Where there is x, we plug in the x coordinate we have found, and then we find the y coordinate. So we're going to say y is equal to negative x squared minus 6x minus 5. Where there is x, we plug in negative 3, since that is the x coordinate. Squared minus 6, negative 3, minus 5, and then we solve. So y is equal to negative 3 squared is going to give us positive 9 squared, positive 9, which is like that. Okay, that's a positive. And then negative times negative is a positive. 6 times 3 gives us 18, and we have a negative 5 there. Y is equal to negative times positive is negative. Okay, plus 18 minus 5 y is equal to here. When the signs are different, we take the sign of the bigger number, which is going to be a positive. 18 minus 9, 9 minus 5. My mind is racing to the answer. Okay, so meaning the value of y is simply going to be positive what? Positive 4. Therefore, the coordinates of the turning point are going to be, what is the x coordinate? Negative 3, comma, the y coordinate? Positive 4. And we are done. Alright, so we're pretty much done with this topic. In the next session, we're going to conclude on quadratic equations. We have one more session to deal with in quadratic equations, and then the only thing we have left will be the test, which will be on Tuesday at 20:30. If it's not 20 hours. Yeah, either 20 hours or 20:30. I've forgotten what time I indicated. Yeah, so in case you got left behind at any point, kindly rewind the video and pick it up from where you got left behind and try to follow through carefully. But in case you still get to have challenges, simply reach out and I'll be able to assist you. Otherwise, thank you for watching. I'll see you in the next one.